Hi, I'm Carly. In this video, we will explore together the detailed procedure for configuring analog inputs and outputs of our EB80 system within the Siemens TIA portal development environment. I will guide you step by step through the process in a simple and clear way. Stay with me to discover everything there is to know about this topic. The EB80 has modules for managing analog signals, modules with 4 analog inputs, modules with 4 analog inputs for temperature measurement, and modules with 4 analog outputs. Before adding the analog modules to the configuration, it is necessary to click on EB80, right-click, and select Properties. Within the Module Parameters section, it is important to configure the following parameters: visualization of analog input and analog input data format. These settings define how analog data will be displayed and managed within the system. The visualization of analog value parameter allows selecting the logic for managing incoming analog data, choosing between two modes. Motorola Big Endian is the default mode. The sequence starts from the most significant byte, MSB, and ends with the least significant byte, LSB. Intel Little Endian. In this case, the sequence starts from the least significant byte, LSB, and ends with the most significant byte, MSB. The other parameter, analog input data format, can be configured in two modes. Sign plus 15-bit, the analog value is represented with one sign bit and 15 bits for the value, useful for bipolar signals, for example, ±10 volts. Linear scale is the default setting. In this case, the read analog value is linearly scaled based on the value defined in the user full scale field of each analog channel. This allows a direct and engineered representation of the signal according to the set range. To add the analog input and output modules to the configuration, double-click on EB80 in the hardware configuration. From the hardware catalog on the right, select analog modules and proceed as follows. Drag the 4 analog input module into the configuration to add it to our EB80 device. Drag the 4 analog output module into the configuration to add it to our EB80 device. Finally, drag the 4 analog input for temperature measurement module into the configuration to complete the insertion of the analog modules. By selecting the 4 analog input module, right-click and open Properties, then access the Module Parameters section. Within this section, the 4 analog channels available on the device are displayed. For each channel, it is possible to enable or disable it and configure the type of input signal, choosing from the following options: 0 to 10 volts, -10 to +10 volts, 0 to 5 volts, -5 to +5 volts, 1 to 5 volts, 0 to 20 mA, 4 to 20 mA, -20 to +20 mA. Next, the filter measured value option is available. This function applies a moving average filter, which stabilizes the reading of the analog signal. Up to 64 samples can be selected. The module will calculate the average of the measured values based on the number of samples set, reducing fluctuations and making the reading more stable and reliable. The User Full Scale field allows setting a custom full scale for each analog input signal. This setting can be defined individually for each channel, allowing the reading to be adapted to the specific values of your plant or sensor. Continuing with the configuration of the analog outputs, select the 4 analog output module, right-click, and then access Properties, Module Parameters. In this case as well, it is possible to modify the settings for each individual channel. In particular, the signal range can be selected according to the desired type of analog output: 0 to 10 volts, -10 to +10 volts, 0 to 5 volts, -5 to +5 volts, 0 to 20 mA, 4 to 20 mA. Monitor lower value. This function, if enabled, checks that the value received from the master is not below the minimum value defined in the lowest value field. Monitor highest value. Similarly, this function, if enabled, checks that the value received from the master does not exceed the maximum value defined in the highest value field. Failsafe output. This allows defining the state of the analog output in case of communication interruption with the master, for example, in the event of PROFINET communication loss. The available options are: hold last state keeps the output in the state it was in before the communication error. Fault mode value sets the output to a predefined default value specified in the fault mode value field. In the user full scale field, we define the scale of the analog output, that is, the maximum value, full scale, corresponding to the maximum analog signal delivered. The lower value parameter represents the minimum reference value that will be checked if the monitor lower value control is enabled. Similarly, highest value is the maximum value used in the monitor highest value control if active. These settings can be configured individually for each analog channel. By selecting the 4-input module for temperature measurement, right-clicking and choosing Properties, we can access the module parameters. In this section, it is possible to configure the card settings in detail for temperature reading. Unit of measurement, we can choose between degrees Celsius and Fahrenheit. Noise reaction 50 Hz allows suppressing electrical noise generated by the power network. Sensor adjustment allows selecting the type of sensor used among the supported ones. Various sensors can be chosen as shown in this window. Connection technology allows selecting the type of connection to use for each channel. The available options are 2-wire, 3-wire, or 4-wire connection. Cold junction compensation allows selecting the use of an external cold junction instead of the one already mounted internally. Measure resolution allows setting the measurement resolution in tenths or hundredths of a degree. Signal disconnection, sensor, if enabled, disconnection of the sensor generates an alarm. Short circuit signaling, if enabled, a short circuit in the sensor connection generates an alarm. Monitor lower value. Enabling this function allows generating an alarm if the temperature falls below the set minimum value. Monitor highest value. Enabling this function allows generating an alarm if the temperature exceeds the set maximum value. In both cases, the values are entered in these two fields. Filter measurement value is a mathematical filter of up to 64 samples, which allows obtaining a more stable temperature reading. Acquisition filter defines the type of digital filter for noise suppression. These settings can be parameterized individually for each temperature input. After completing the settings for all analog input and output modules, we proceed by selecting our PLC, right-clicking, and then choosing Compile to start compiling the hardware configuration. At the end of the compilation, we right-click on the PLC again and select Load to download the hardware configuration to the device and execute the upload. Once the download is complete, to verify that our hardware configuration has been correctly downloaded, we click on Go Online. As we can see, the hardware configuration is completely green, indicating that the download was successfully completed. By double-clicking on the device, it is possible to write and monitor the memory areas associated with it to verify correct data exchange and the functioning of the application. Great job! I hope that this guide has been useful and clear for you. Thank you for having followed this video with me.